Welcome to the Simple Harmonic Motion Glider Attached to a Spring video. In Exercise 1, we'll be setting up the equipment and calibrating the force sensor.
Hang the force sensor from a stand and attach it to the analog port on your data acquisition interface.
Hang a known mass from the sensor.
Open Data Studio and select Create Experiment. Click the first analog jack and select Force Sensor. Set the sample rate to 250 Hz and the sensitivity to medium. Click Calibrate Sensors, and in the 0.1 section, enter the force in newtons that your known mass is exerting on the sensor. Click Read from Sensor.
Replace the mass hanging from the sensor with a second known mass.
In the 0.2 section, enter the force this mass exerts on the sensor, and click Read from Sensor and OK.
In Exercise 2, we'll be using the force sensor to find the period of oscillation of the glider and in turn the spring constant K.
Hang the spring from the force sensor and measure its mass to make sure the assumption that it is massless is reasonable.
Turn on the blower. Set a glider on the track. If it moves, level the air track by rotating the feet at the appropriate end.
Fix the spring to one end of the air track. Fix the other end of the spring to the glider. Attach a second spring to the other end of the glider. The final end will need to be attached to the force sensor. Arrange the stand and force sensor to make this possible.
Press Start in Data Studio and set the glider in motion. Record about 20 oscillations. Note that large amplitudes are not necessary.
Add mass to the top of the glider and repeat for at least 5 different masses. We recommend adding larger masses first for practical reasons.
In Exercise 3, we'll be finding the spring constant using Hooke's law, a force sensor, and a motion sensor.
Set up a stand at one end of the track. Arrange the force sensor and motion sensor as shown. Plug the motion sensor into the data acquisition interface with the yellow plug in port 1.
In Data Studio, click Setup, click the first digital port, and select Motion Sensor. Change the sample rate to 25 Hz. Create a graph of force versus position. Tape a flag to the glider and attach it to the force sensor with a spring. Press Tear on the force sensor, press Start in Data Studio, pull the glider back, and press Stop.
In Exercise 4, we'll be repeating Exercise 3 with springs in series and parallel and investigating the effects on the spring constant.
Remove the spring and add a second spring in series. Repeat the previous measurement. Also do this for 2 springs in parallel.
What did the neutrino say to the Higgs boson?
Here's another fine mass you've gotten me into.